Good day everyone. In this video I will be talking about differentiation. I know there are some functions that you will use both quotient rule and function of a function. So we are going to talking about functions of this kind. Thank you and God bless you. Please don't share this video. Make sure you like it. It's okay. Let's look at it together. Differentiation using chain rule and quotient rule. Amen. Okay. So let's look at the function differentiation using chain rule and quotient rule. Assuming you have a function of this form, if y is equals to x minus 1 all over x plus 1 square root of this, we said find the y all over the x. Simple as ABC. Okay, let's write solution. Amen. Let's write solution. Please make sure you follow me. Listen very attentively. Is that clear? Okay, y is equals to x minus 1 all over x plus 1 square root of this. This is the function. So looking at this function is a very simple function to differentiate, but I know very well that people will find it difficult. Why? Because we have a square root and at the same time we have inside the square root we have a function dividing another function. So how do we differentiate this function? And that is why I said differentiation using chain rule and what? Quotient rule. It means we are going to apply these three rules. So whenever you come across functions of this form, you make use of this. You use these two rules. So we are going to make use of these two rules. Okay. Now, before we can differentiate this function, I want us to know something. Go back to your indices. If we have 2x plus, let's just do it this way. X minus 1 all in bracket square root. You know that in indices this is the same thing as x minus 1 raised to the power of 1 all over 2, true or false? But before you can differentiate this function, you must transform it this way, true or false? Okay, so if you agree with me, if you can see what I am saying, we will write it this way, we'll write this function this way. Y is equals to x minus 1 all over x plus 1 all in bracket raised to the power of 1 all over 2. Amen. So this implies that this is the same thing as this. Okay. So now how can we differentiate this function? Before we can differentiate this function, we will now say either we will say let p, any alphabet, be equals to what is inside this bracket. That is x minus 1 all over x plus 1. Amen. So this implies that your y is equals to p raised to the, because anywhere you see y, that is your p, this x minus 1 all over x plus 1 is p. So instead of this, we are writing p here. So, but note that this function x minus 1 all over x plus 1 is raised to the powers of half, isn't it? So 1 all over half. So you can now see that we have gotten our chain rule, true or false. That is, It means we are going to apply chain rule to resolve this. But here, P here, we will use a quotient rule to obtain our dy, dp all over dx. Okay? So let us just consider differentiate with respect to p, that is y equals to p raised to the power of 1 all over. So our dy all over dp is going to give us what? 1 all over 2 p raised to the power of minus 1 all over 2. True or false? Because, why? Because this is how you are going to have it. 1 all over p, 2 p raised to the power of 1 all over 2 minus 1. So if you take the LCM, it's going to be what? Minus 1 all over 2. So take note. Is that clear? Okay? So if you agree with me, a dy all over dp will give us this. Then how do we obtain our dy all over dp? Because we want to differentiate this function with respect to x. So we are going to use a quotient rule. So now we write to obtain, okay? Let's write to obtain, amen, dp all over the x. We now use a quotient rule. Then the quotient rule is given as that is, since the dependent variable here is what? P. So P is equals to U all over the V, isn't it? So our dP all over the X is going to give us what? U dV all over the X minus V du all over the X all over V squared. Amen? Okay? So do you agree with me? So we are going to use this formula to obtain our dP all over the x. Is that clear? So you don't need the prophet to tell you. This is the function. P is equals to x minus 1 all over x plus 1. So as it is, which one is supposed to be your u and your v? You don't need to just equate it. U all over v. So it implies that we now write let u equals to x minus 1 and v equals to what? X plus 1. True or false? Are you following? Okay? So if you agree with me, we differentiate this function with respect to x. Our d all over the x is equals to 1, isn't it? Because this minus 1 is a constant. So if you differentiate x, it will always give you 1. Then our dv all over the x is equals to this plus 1 is a constant. If you differentiate it, it's 0. So if you differentiate x, it will give you what? 1. So now we are going to substitute into this formula. So if you agree with me, amen. If you agree with me, our dp all over the x is going to be, what is our ordinary u? Our ordinary u is x minus 1. So let's write x minus 1. What is our dv all over the x? Is 1 times 1, isn't it? Now what we have here, minus, what is our ordinary v? Ordinary v is x, make sure you put the bracket because of this minus sign, x plus 1. Then what is our ordinary, what is our du all over the x? Our du all over the x is 1, amen? Is 1. Then all over v squared. So what is our v? Our v is x plus 1 all in what? Square. Amen? So if you can see what I am saying, it means we can multiply out these two brackets. So if we multiply out these two brackets, our dp all over the x times 1 will give us x, minus 1 times 1 minus 1. Then use this, okay, assume that the 1, okay, let's do it this way for the sake of manias, amen. 1, yes, let's do it this way, minus, okay. So minus 1 times x is going to give us minus x, amen. So minus 1 times x is going to give us minus x. Minus 1 times plus 1 is going to give us minus 1. Is that clear? So all over x plus 1 all in square, which is equals to, you don't need a prophet to tell you this and this will go, true or false. So if you agree with me, minus 1 minus 1 we're going to give us minus 2 all over x plus 1 all in square. So our dp all over the x is equals to minus 2 all over x plus 1 all in square. Amen? Okay? So, yes. So we are able to obtain the p all over the x. So what next is for us to form our chain rule. Is that clear? Since now we have our dy all over the p and the p all over the x. So the product of these two answers is our chain rule. Okay? So can I clean this up? Okay? So if you agree with me, let me clean this up. If you agree with me, it implies that, this implies that our, you can now see that we have used quotient rule. Now we want to use chain rule to obtain the final answer, true or false. So now we can now write our, since we are talking about dy all over the x is equals to the product of these two answers. So our dy all over the p times the p all over the x. So this is equals to dy all over the p dot the p all over the x. Is that clear? Yes. One may ask, why not the p all over the x before the y all over? Yes, you know, multiplication is commutative. So whichever way, if you want to first write the p all over the x, use the multiply the y all over the x, you are right. Is that clear? Don't be confused. So our dy all over the x is equals to, what is our dy all over the p? Is what? 1 all over 2 p raised to the power of minus 1 all over 2. Then times the p all over the x is minus 2 all over x plus 1 raised to the powers of 2. True or false? So, yeah. Note that your p is equal to what? X minus 1 all over x plus 1. So don't forget your p. Is that clear? So can I clean here? Okay. So if you agree with me, this implies that our dy all over the x is equals to, we can write this way. This is the same as our p. Instead of p, we write x minus 1. This is our p. All over x plus 1, isn't it? Then note that p is raised to the powers of what? Minus 1 all over, all in bracket, minus 1 all over 2, then all over 2. Is that clear? It's the same thing as half. Then times 2 all over x plus 1 all in what? Square. True or false? So if you can see what I have seen, either you leave it this way or this and this will go. True or false? If this and this go, it implies that we are going to have our final answer will be our dy all over the x is equals to x minus 1 all over x plus 1 all in bracket raised to the power of minus 1 all over 2 times 1 all over x plus 1 all in square, x plus 1 all in bracket raised to the powers of 2. So this is how you are going to solve this kind of problem. Any question? No question? Thank you and God bless you.